Hey guys, welcome back in. Mr. Marone here. So we are into section 6.5, and I mentioned in previous sections when we were starting parallelograms that you would start to see a lot of figures that are parallelograms that you wouldn't know on the outset were actually parallelograms, but they are. And we're going to look at 3 of them today. So these are all known as special parallelograms. So everything that we knew about them prior, all 5 properties that the opposite sides were congruent, opposite sides parallel, the consecutive angles are supplementary, all of that stuff is still true. These are now special conditions. They're like extra steps. So they're just more detailed versions or more specific versions of parallelograms. But please keep in mind that they are still parallelograms. So the first one we're going to look at is the rhombus. And a rhombus, as you can see in the definition right here, it's a parallelogram where all the sides have the same exact length. So it's specific where all 4 sides are exactly the same. And there are 2 things that come out of this that is important to note. The first part is if I've got a rhombus, the diagonals are perpendicular bisectors of each other. Okay, so we know that the diagonals bisect each other. In this case, they also create right angles. Okay, so I've got 4 right angles in the middle of my my rhombus, and they create 4 right triangles here. The second thing that we know about rhombuses or rhombi is that each of the diagonals bisects a pair of opposite angles. So if I were to draw in my diagonals to this rhombus, 1 and 2 would end up being the same thing. 3 and 4 would be the same thing. 5 and 6 would be the same thing. 7 and 8 would be the same thing. So we end up with 4 sets of bisected angles. These would be bisected up here, and so on and so forth. So those are 2 more specific things that are true just about rhombuses. So if we look closely at these 2 examples, they tell us that we've got a rhombus here, and they want to know what's the angle, measure of angle ADE. So they want this angle down here. Well, if we know it's a rhombus, I know that this angle A has been bisected, and that I've got 53 degrees right there. I also know that my diagonals are perpendicular, so I know that that's a 90-degree angle. So I can do 90 plus 53 and get 143, and then just subtract from 180 to get my final answer of 37 degrees. And so angle ADE is equal to 37 degrees. So that's a really good example of utilizing the properties there. So now they have given us an example 2. Quadrilateral GHJK is a rhombus, and they want to know this side length over here. Well, we know that the diagonals of every parallelogram bisect each other. So I know that 2x plus 3 and 4x minus 7 are the same thing. So I can set those equal to each other and then solve out to get x. And I'm going to go ahead and solve that quick. You guys do the same. So I got x equals 5. Well, since a rhombus has 4 congruent sides on the outside, if I plug into this 3x plus 1, that's going to give me length of hj, which is the same length as gh. So hj is equal to 16, so gh is equal to the same thing, 16. So that's the rhombus. It's a parallelogram with 4 congruent sides. Our second special parallelogram is the rectangle, one that you guys are very, very familiar with. And a rectangle is simply a parallelogram with 4 right angles. So all of the rectangles, which we already knew have right angles, they have 2 sets of congruent sides, all of that good stuff. And it gives us one thing to work off of. If I've got a rectangle, the diagonals are congruent. So the diagonals will be the same exact measure in our rectangle. It's not true of the rhombus, not true of the parallelogram, but specific to our rectangle. So let's take a look at an example here. So they say that Paul is training his horse to run this course, which is a rectangle. They tell us that the figure is a rectangle right here. So they tell us it's a rectangle right here. And they tell us that he's training them at a pace of 4 meters per second or faster. And it says that Paul rides his horse from D to C to E to B in 1 minute and 30 seconds, or 90 seconds. Did he make his goal? In other words, they want to know, did he run fast enough? So if we look closely, because AB is the same thing as CD, that tells me that this is 192 meters. And since I've got 80 here, 80 is also going to go over here. And we can find the length of AC using Pythagorean theorem. So I can do 80 squared plus 192 squared, and that's going to give me the whole length. Or in other words, it's going to give me AC squared. And the nice part about this is that once we have that, EC is half that length. So go ahead and do your math on that. Figure out what your Pythagorean theorem is and see what the measure of AC is. Go ahead right now. Okay, welcome back in. So AC's length was 208. So cutting that in half means that this was 104 and this is 104 as well. So if I add those up, I'm going to have, if he ran from D to C to E to B, I've got 192 plus 104 plus 104. So he ran a total of 400 meters. And his goal was to run at a pace of 4 meters per second. So if I do 400 meters and I divide by the 90 seconds that we had, he ran at 4.44 meters per second. So he did not make his goal. No, he didn't. Now the final one that we're going to look at is really simple because it's something you've dealt with many, many, many times. And it's really just a combination of everything. And that's the square. The square is a parallelogram with 4 congruent sides and 4 right angles. So it's a combination of the rectangle and the rhombus put together. And basically everything is true about it. So if we look down here, we've got right angles in the middle. We've got congruent diagonals. We've got 4 congruent sides. We've got 4 right angles on the outside. It's just got everything. They're very, very simple to work with because basically everything is equal to everything. I know that's generalizing, but it's kind of true. So take a look at your practice problems. Let me know if you have any questions and bring those with you back into class tomorrow. Have a great day, guys. Bye-bye.